Muchas gracias, Carolina.
Muchas gracias,
Buen día a todos.
Thank you, Carolina. Good morning, everyone. It's a pleasure to be here with you again in Alacero Summit.
Very short introduction of this panel. We have been talking about mainly what's going on outside the door of our production facilities, what are the trends in the world regarding conflict, regarding trade, regarding politics, etc., and etc. Let's look a little bit what's going on inside our production units, taking into account all the industrial revolution, technological revolution that's taking place, taking into account also the decarbonization wave that is gaining momentum. And let's see how you as engineering firms are helping the industry in solving the decarbonization process on one side, and on the other side as well, to gain productivity or to gain efficiency in terms of flexibility instead of production efficiency, in terms of safety for our people, in terms of quality control, etc., and etc. So today we have three distinguished panelists from very well-known engineering companies as PRIMETALS, DANIELI, and RUSSULA. So let's go with the first speaker, Kurt Herzog. Please, go ahead.
Hello, everyone. Thank you for the opportunity to be here. My first time at Alacero. I'm very happy to talk about digital technologies and how they support autonomous and green steel production. I will not talk about digital technologies themselves. Why? Every one of you has a mobile phone in his pocket. Hopefully it's in the pocket and you're not reading your emails, but listening carefully. Making photos is okay. We use a mobile phone every day. Why? Give you an example. I'm a foreigner in Sao Paulo. I like my mobile phone. It helps me to find my way. And I don't care what technology is behind it. I like it because it solves my problems. And the same is valid for steel production. There is a whole bunch of digital technologies out there and they all sound fancy, but the question is, how do we use them? For which purpose do we use them? And there is many areas where digital solutions, where automation, where digital technologies can support. And what's on the slide is just a selection of challenges steel producers are facing day by day. It's about producing quality, achieving target quality, not overachieve, not underachieve. That also needs process quality. How stable, how consistent is a production process? Productivity is obvious. Flexibility gets more and more important. On the one hand, being more flexible towards your customers, flexibly react to the demands of your customers on the one hand. On the other hand, being more flexible in using different raw materials, maybe using different energy forms, green energy forms instead of traditional energy. So flexibility can be supported a lot. Safety, we heard this morning already in the entry speech, is a very important topic there. Digitalization can support environment, CO2 reduction for sure. And at the end of the day, it all sums up at costs, which is a decisive factor for business success. In my today's short presentation, I've picked out two aspects where I want to a little bit elaborate where digitalization solutions and in which way they can support you in solving your challenges. And I'm starting with people. People are a decisive factor. In the past very much people were seen as a cost factor. This is still true. Okay, that gives me a challenge. It's just a digital system. People are still a cost factor, that is true, but an additional challenge is coming up, and that fits quite well to what we've heard in the morning, that TERNIUM received an award for their best training program. So having good people is a huge challenge. Having sufficient people and sufficiently qualified people is a huge challenge. And there, digitalization can support a lot. In two ways. On the one hand, using digital systems and automatic systems, robots and things like that, to reduce manual work. But more important in future will be people are not only manually working, but they are making decisions. And decisions are the result of input information and know-how. And if you want to well operate your plant, you need people with know-how. And if you don't have the people, they will not make the right decisions and your production will not work well. If you bring this know-how into a digital system, combine it with the information coming out of the automation systems, the plant itself can make better decisions, and that's decisive, it makes consistent decisions. Maybe it's not the best decision, but it's consistent, and it's a starting point for continuous improvement. So if the rules, the models, the decision is based on are not perfect, you can improve them, and then you can be sure that this is consistently applied in future. That means you digitize your one best operator and can be sure that on all shifts the best operator is acting. It's maybe a little bit of a shortcut, but this is the way we think and the direction we are working in when we talk about increasing the autonomy level of a plant. Automate decisions. Support with better information to make decisions. And that reduces the need for human intervention, and humans make mistakes. And by reducing these mistakes, that leads to improved quality, increased productivity, enhanced flexibility, if those principles are applied in the respective areas. This does not happen at once, so this is some sort of journey. We start with a very low level of autonomy, basic automation, maybe not even a process optimization or things like that, and develop more and more towards a higher degree of autonomy. Maybe one person can in future operate one plant, or even the plant acts totally autonomously, but this is for sure future. What we are currently working on is systems that support one person operation per plant. That needs a lot of different technologies applied and the different support systems. The central system, I will just show this one due to time restrictions. The central system is a central operation cockpit we have developed. And the idea here is not to present all the information to the operator, but to only present the information that is relevant to make the right decision, to prepare decisions that are just confirmed by the operator based on the data we get out of the plant, and have a standard operation running actually without interference of the operator, and in specific cases where it is necessary, the operator gets the full support, gets all the relevant information, gets proposals what to do next. And with the support systems, operators, one person can operate an entire plant. That is one aspect, plant autonomy and how we support people in making better decisions, making a better job. The second one, CO2 reduction. Decarbonization, the ones who have been here last year, they maybe remember what my colleague Alexandre was talking about. We see that decarbonization will happen in 3 phases. In the first phase, it is more or less optimization of the existing assets and technologies. A transition phase, using partially hydrogen, using new technologies to reduce carbon with a potential of 30 to 40%. And then finally, green steel, maybe starting in 2030, hydrogen-based DRI plants, renewable energy, and carbon capture technologies will allow that. I will only refer to the first phase and what automation and digital systems can do there, because I assume that in phase 2 and 3, the plants will be fully digitized anyhow. Automation and digitalization can support in many areas, and the beauty is that there is no large investment involved. Compared to installing a new technology, installing an optimization system is a rather low investment, and usually it's not only about CO2 reduction, there is additional benefits out of those systems that ensure a very short return on invest time. So where are the anchor points? Where can digitalization, where can automation support here? One of the main factors I see is on the output side, increase the yield. Whatever you cut off and scrap in steel production, in the entire production chain, goes back to the beginning and needs to be remelted. All CO2 that is related to these pieces is wasted CO2. So increasing the yield automatically reduces the rate of carbon dioxide that is related to the sold and used product. That's a huge lever. On the input side, if it is acceptable by the process, which we cannot change, we can maximize the use of friendly raw materials, which always needs automation support, process models that pre-calculate is this possible or not. Minimize energy demand. It is very often very simple, and when we talk about process, we always have in mind the blast furnace, the converter, the electric arc furnace. Very rarely we talk about water treatment plants. I still have it in my ears. My mom used to say, please turn off the lights when you leave the room. So when you go back to your plants, check if the cooling water pumps are turned off when they are not needed. And it is so simple, and with minimum investment in turning the pumps off automatically when they are not needed, you can save a lot of energy, and energy always is related to CO2. So minimize the energy demand, and for sure optimizing the processes is a contribution as well. But it's not always the highly complex things, it's the simple things. And for sure, maximize the usage of green energy if it is available. 3 examples, 3 success stories from our side where with our digital solutions we could support our customers in those aspects. The first one is from a project in China where I have implemented a quality through process quality control system that steers the product quality along the entire chain, does predictions, property predictions, predefines process parameters for the next production steps to ensure that the final quality of the product is according to the needs. And just one number here, we could reduce the rejection rate by 12%. So this is a quite a success regarding productivity, and as I said, the yield was increased as well, so it also has an impact on CO2. Next one, process optimization system with expert system and prediction models on a blast furnace, stabilized and optimized the production. The figures here are from the annual report of our customer, and this is mainly due to the reduction of coke that is used in the process, and that also means a huge reduction of CO2 emissions. So again, it's not only about CO2 or not only about autonomous plant operation, it is both. And the last one, one example for our central operation cockpit for a customer in China on a hot strip mill, we could reduce the number of needed operators from 6 to 2 to run the entire hot strip mill. To summarize, the digital solutions and the automation can support in optimizing plant performance and reduce manual interventions and increase the autonomy by combining data and information with digitized know-how that you can continuously grow. For CO2 emission reduction, the nice thing about the automation solutions is whatever you do, it pays back in a very short period of time, and it is not coming with a huge investment. Last not least, all the digital technologies that are available are just a tool set, and they only bring a benefit if they are applied properly, not only in the area of autonomous plant operation and CO2 reduction. Thank you very much.
Thank you, Kurt. Let's go now to our second speaker is Rolando Paolone from DANIELI Group. He's CEO and CTO of DANIELI Group. Thank you for being with us, Rolando.
Yeah, thank you very much for this invitation, and let's start this journey. We have 10 minutes to go, so we need to go fast. Okay, there is here a movie. There should be a movie. Maybe the movie is coming. It's not coming. Okay. This is the DANIELI Digimelter. Everybody knows about what is an electrical arc furnace. This is the old solution. This is the new solution. What is new here is digital. So it's not more analytic, it's digital. The electrodes are managed by the Q1. I think that more or less everybody knows about what is Q1 today, but it's a way to manage the arc from the electrodes in a digital manner. In some ways, it's like to run a motor with the frequency variation, let's say, for the speed. This technology has been, we started to work on this 2015 about. We did it in a plant close by our company. And we make this experiment. It was an experiment. We worked a couple of years on this small furnace. It was a very small furnace. Then we did it one step forward. Then on 2019, I was in Leoben, another meeting similar to this one, and I was informing the people that 4 months later, we will have the first real plant in Sisak, Croatia, feed by the Q1. This plant is a DANIELI plant, is part of the group. We are producing steel there. And so 2019, 2020, springtime, we had the first Q1, the real one, in operation. Today we have 44 projects running. Running does not mean they are all in operation, but there are 8 in operations, and the rest is under design, under manufacturing, and so on. So in 4 years, we practically populate all the world, more or less, different places in the world with this new solution. Okay, just to summarize a couple of numbers about this, let me call it success. We can save energy, because the system is able to save energy thanks to the best manage of the electrodes of the arc. It's faster in the tap to tap, faster to close the melting and cast. So it's giving more production with the same ladle. Electric consumption of electrodes is less, and also the direct emissions compared to the traditional EAF is practically reduced by 60%. This is not just Q1, it is the design of the system. Okay, the next point is the Energiron. Energiron is a process that developed together with Tenova. It is a direct reduction plant. It is potentially the alternative to the blast furnace, BF-BOF solution. We are in the mine, let's say, stream. We are producing steel using iron ore, and this solution has the benefit to reduce dramatically the emissions. This solution is also ready to become hydrogen instead of gas. Today is with natural gas. The direct reduction is done with natural gas, but it can be used, we can use also hydrogen. There are already plants that are starting to think to use hydrogen. One is in SSIB in Sweden. The name of the prototype is Hybrid. There is another company there that is thinking to go in the same direction in Sweden. Why Sweden? Because Sweden is having electrical green energy with a low cost. And that is very important for this product, as it is using a lot of energy to produce hydrogen. And so that solution is, okay, to come, let me put in this way, but okay. Anyhow, with the natural gas, the emissions are dramatically reduced compared to blast furnace, BF, BOF, more or less half or less if you use some capture of the emissions. Again, some numbers to fix, let's say, about this technology. 82% is the reduction of the CO2 emissions if we use hydrogen. 70, okay, is vice versa, but anyhow, is 60-70% the reduction, practically 80 is net zero, let's say, if we use hydrogen. Lower emissions of NOx, and the metallization is at the level that you see. Another technology that we develop is the DANIELI Universal Endless. Here we are in the flat product. We are in the production of strip product. And the technology we develop this plant, the first plant we develop is in China, Shougan, Jintang. This was 2019. Now we have another 4 plants under manufacturing and going to be supplied. The advantages of this solution is that we are able to be a lot flexible with this technology. So, for example, if you want to produce from 0.8 millimeters thickness to 25, this equipment is able to do it, while normally you need 2 mills. Why is able? Because it's able to go to coil, semi-endless or endless. This is the plus of the technology. The other point is that the casting is performing very well. So we are able to do up to 4 million tons per year of production, of output, while normally to do that you need 2 plants. What else? We can maybe see the summarizing table. Dynamic width and thickness adjustment. That is possible without stopping because we are in endless, so we need to be able to do that to change production and so on. As I said, more than 4 million tons per year with one strand, with one plant. The saving of CO2 is about 50%. 50% also considering that in some cases, for some product, for some application, I mean, we can avoid to use the cold mill after this mill. We are always talking, as you see in all the presentations, about CO2 because, okay, in Europe, starting from Europe, everybody is thinking that we need to reduce CO2, so we are working on that. Reduction of CO2, anyhow, is for DANIELI something that came free, let's say, because we start to think that we need, long time ago, to reduce the OPEX for the customer. Because the customer needs to be competitive, so maybe he will gain money and come back to buy the second mill or the second plant. So the reduction of OPEX is giving benefit to the customer, but is giving benefit to the environment because less resources, it means that you are burning less material, you are handling less things, and so on. This that you see on the screen is the MIDA. MIDA technology, the mini mill DANIELI for long product. Here is another story of success, sorry for repeating myself. 2008, we did the first plant in United States, CMC. CMC is a commercial melting company in the US. It was a challenge between the owner and our owner. On that time, they said, we need to make a small mill able to fulfill the production, the local production, collecting the scrap in the area and delivering final product in the area. The cost should be as minimum as possible, and the OPEX should be as low as possible. Okay, we went for an endless, but the main important thing is that we remove the reheating furnace. There is no reheating furnace in this technology. There is the melting, there is the, now, of course, with the Q1, there is the casting, and directly we go through the rolling mill. This means that we don't use any gas to reheat. We use the heat of the casting. And this is, of course, giving a big advantage in terms of cost, production cost, OPEX. there is another advantage, which is the fact that rolling continuously, endless, you can minimize the dimension of the wire rod, of the bar, or whatever. Because in the rebar world, let's say, it's possible to sell the bar within a certain range of tolerance dimension. So you can go to the very minimum one, so you use less liquid to produce more steel. And this is something that is giving a big benefit, a big advantage, another big advantage. One is saving the gas, the other one is being able to use better the steel, the liquid steel. And today we are able to do not just bars, that was the very first plan, but we're able to do spooler lines and wire rod lines. In these weeks, we are commissioning a plant, another plant, again with CMC in Arizona, that will go for merchant bar. So this is another step, because a rebar is common, let's say, to work one day with the same product, same dimension. But when you go to merchant bar, the changes are frequent. And so this is another, okay, changes are frequent, so you need to stop the casting, because you have to change many stands. And this is the other challenge that we have now on the table. Summarizing, the speed of the casting is a key point, because we are in endless, so we have only one strand. We are now running close to 10 meters per minute with the casting, which the common speed for this kind of steels is less than 6, 5.5, 5. The very first plant started with 6. And then we improved the same plant, and you can understand that the production has been increased by about 50%. So 200,000 tons per year the beginning, and they do more than 300,000. The yield is so high compared to normal 94, 95, 96 for a very good management of the mill, because there is no cut. There is no head and tail cut. There are less cables, because the bar is a continuous bar. There are no heads entering the next mill, and so on. And at the end, which is all the blah blah, but at the very end, the number that you see here on the right side is what makes the difference. We can save 50 USD per ton. So this means that in a transformation cost that is probably less than 300, 250, you save 50. And this is the reason why today in the United States, the way to do rebar is this. In Europe, we are stepping a little bit, not so fast, let's say, but we have 4 plants potentially, 4 orders that are hot, as we say. In India, we installed the first one. We get the first order with Tata Steel. Tata Steel is recognized in India, so we expect that many other producers will come for this technology. Numbers, 2008, we start to develop this technology. 8 years, nothing happened. Okay, so one plant running, no one customer was trying to follow this idea. Then the same customer did the second plant. After that, it was a booming, of course, a booming of plants. So 2008, the first one, 2016, the second one, today, 25. That's it. What's next? We think that next, well, our colleagues, my colleagues already spoke about this, and I think RUSSULA, if I understand well, will go deeply in this, the concept of digitalization. So, of course, what I presented before is change of process, important changes, not just optimizations. But probably the next step will be not so easy to change again the process. So we think we trust a lot in the digitalization, artificial intelligence, and so on. Everybody's talking about this. Somebody is also, I go fast because I see my time is gone, but some people, I say, they are talking about this, many people. What is true is that this is a way to run a mill in ABS. ABS is our steel plant. So there are no people around. The guys are sitting there. As you see, are both young, below 25. And this is the way to handle a mill. But this is still automation, let's say a certain level of automation. These are the packages that we have practically available, not all ready for the market, about artificial intelligence. One of the most interesting, I think, is mechanical properties prediction, which is a system that is able to tell you if you will reach that mechanical property with your coil, for example, putting into the computer, into the system, all the chemical, all the the reduction in the stands, temperature in the various steps, and so on. This one is on the market, we can sell it. The advantage for all this is what? That you can increase quality, you can reduce the loss of material, second quality, and so on. Okay, I think I have to close, otherwise they kick me off from the stage. Thank you very much.
Thank you, Rolando. Our next speaker, Alexandre Schultz from RUSSULA. Please, Alexandre.
Bom dia a todos. Congratulations, Kurt. Congratulations. Orlando, sorry. Eu gostaria de agradecer à organização do Alacero pelo convite.
I'd like to thank Alacero for this invitation. It's a pleasure for me to be here to talk about innovation and technology. When RUSSULA now celebrates its 25th anniversary of developing solutions, making the steel industry safer and more autonomous. I'd like to show you a video that was prepared for the 35th anniversary of the company.
Artificial intelligence, non-fossil fuels. The future is today. After 35 years, we're at the forefront of the steel industry. How do we do it? By knowing where we're heading. Excellence, reliability, innovation, sustainability are the four core values that guide us. We strive for excellence. We prioritize reliability. We embrace innovation. And we're committed to sustainability. We know what the future will be like because we're already there. 35th anniversary. RUSSULA.
Bom, inovação em busca de uma indústria cada vez
So
mais
innovation for increasingly more autonomous industry, safety of people, efficiency processes, and sustainability have always been four concepts that have always guided RUSSULA in search for solutions that are applied in three main business segments in our company: rolling, water treatment plants, and digitalization projects. So my goal here is to practically show the application of new technologies for each one of these segments. I had the opportunity to take a course with Abílio Diniz in the Getúlio Vargas Foundation, and he always said that any business depends on two things: people and processes. The importance of people has been broadly addressed also in the last Alacero business. The importance of the right people at the right place, the importance of HR in the corporation, and the importance of leaders that dedicate more than 70% of their time investing on people. I can easily say that if it weren't for the people that are part of the team today in the company, our company wouldn't be where we are today. And if I could define in two words, I would use commitment and teamwork. But for today's subject, it is in the processes. That's where the greatest opportunities are for the use of new technologies with the goal of leveraging the profitability of the industry. I really like this definition of digitalization. Of course, there are several definitions, each one can have their own, but this is very simple to us and straight to the point. Digitalization is the opportunity to transform data from process into value. And value here, it doesn't mean only money, but also the personal safety of people working within the industry. This is a very important value to RUSSULA, and based on that, some digitalization solutions aim at putting the operator away from the risk environment. Another important aspect that we were mentioning before is quality of information. Quality of information does not mean good results. It's important, of course, it's important to have information, but it's more important to have the ability to analyze the information, because competitiveness is boosted not only by the capacity of obtaining information, but also having functions where I can process the information and get the results from that. How do we implement digitalization in the industry? There's not a one-size-fits-all recipe. I've seen great projects that haven't had the expected results, and I've seen small applications of digitalization become huge projects with great economic and safety results. But there's one thing in common, being large or small, the profound knowledge of the process of the company that is going to do this application of digitalization. That's why RUSSULA, in these 35 years working in the steel industry, develops specific applications for the steel industry. In this sense, around autonomy of the process and safety, we have worked hard and invested in solutions for artificial vision. The goal is to obtain data from processes that were not possible before with existing sensors. So also associated to artificial intelligence, I can forecast actions on the process based on behavior patterns. For example, in the application of artificial vision cameras positioned in the mill in certain positions, with that I can get a digitized image as if it were a scanner of that bar. I can see the form of the material, dimensions, traction, stability, angle, that forever works with rolling, that you know what I'm talking about. Another interesting point for the application of artificial vision solution is in the beginning. Every time I laminate a bar, there is some metal loss. If I have the digitalized bar allowing me to measure exactly where I cut that bar, I can inform the automation system that it made a mistake and reduce this loss. Thinking about cutting this more than 1,000 times a day in a year, that might mean hundreds of tons a year. Thinking about efficiency, I'm going to talk about efficiency in technology with the example of Formula 1. We just had our Grand Prix here. This video shows in 2019, Mercedes doing the pit stop of both pilots at the same time, and then 30 years ago that we did for Ayrton Senna. This is an example of planning technology result in efficiency. So this, likewise, like a Formula 1 car, the mill has to stop. You need to change equipment when you change the product that is being milled. We change the cylinder, the machine setup. A solution developed with the main steel producers in Europe, we developed a system called Mill Pulse, which manages the complete production process of a mill. from end to end, all the process, cylinder workshop, furnaces, laminators, they are all digitized and processed within one single database. And instructions and good indications are passed on to the production manager to make the best decisions, making the mill to idle as little as possible, resulting in efficiency in the process. For sustainability, the fourth concept, we know that the steel industry is by its nature a recycling industry, but that uses a lot of water, and it's a very scarce resource, especially in Latin American countries. The solutions applied to water treatment plants, they aim at reducing the consumption of this resource and reusing it several times within the process with the goal of sometimes zero waste or ensuring quality of the final effluent that is sent to the environment. This is an example of a project developed by RUSSULA and BlueScope Steel in Alacero.
In collaborating with us and not just deliver a standardized solution. We're very impressed with RUSSULA's technical expertise with water systems, being very focused on steel. From the time that we awarded the initial contract, we executed that project in a 12-month window. That's a phenomenal result in a very short amount of time.
Other sustainable solutions are becoming a reality within the steel industry. As for example, the use of gray waters from cities or from other productive equipment that is treated and used within the steel industry. On the side of decarbonization, what we're talking about a lot here, RUSSULA has been working in a pioneer project in Europe and Spain, which is the construction of a rolling mill that is 100% sustainable without emission of CO2, with sustainable and photovoltaic energy, both green hydrogen and wind power. We start operating in 2026 with a capacity of 1.5 million tons, possibly being increased to 2.6 million tons. Besides investing in technology and innovation, we play an important role in social responsibility. In a joint initiative with the Brazil Gerdau Group, part of the income of the projects within the group are reverted to social actions in local community around the mills. As you know, we are taking big strides towards an industry that is increasingly more autonomous, efficient, safe, and sustainable. Thank you very much.
Let's go now to a Q&A session. I have prepared, after hearing your presentation, a couple of questions for each of you. First, Kurt, you speak that the decisions at the job place is taken with input information and know-how. But the risk in this digital revolution is to be overwhelmed with information. How we are going to deal with that? What is the solution? AI?
That has many different aspects. One that can easily be addressed is, CCTV systems, putting more cameras to have more pictures of the plant is something that is happening. And if you watch a soccer match, there is 2 goals in 90 minutes. Two goals in 90 minutes maybe, or maybe it's 3 goals. So actually you watch 90 minutes, but it's only 2 or 3 seconds that are important. If you bring that to the steel production, it is not necessary to show the video streams all the time. It's just necessary to show the video streams when something is happening that is relevant. And what we in addition do is that we enrich the video streams with process information. So we analyze the video streams with artificial intelligence, machine learning models, draw some information out of the video streams, present the information on top of the video streams combined with other process information. So really condense the information and only show it when it is necessary. And by doing that, we can reduce the flood of information. Another thing is preparing decisions. Condense the data to information, apply digitized knowledge, and say, okay, operator, this happened now. We would propose to do this or that, for this or that reason. Do you agree? Yes, off it goes. Or even the decisions are executed automatically when the trust is there that the system does the right things. And by doing that, that allows a reduction of information that is presented to the operator, and less operators can operate an entire plant in an even better quality.
But the operator has to be highly trained in order to do that.
The operator doesn't have to be highly trained in the usual case, but if there is an exceptional case, then he has to be well trained and ready, and this is a challenge which we tackle. And there is one system that is going into operation these days in Brazil with training simulators, saying, okay, the automation takes care that nothing happens, but just in case something happens, that the reaction of the operator is the right one, we provide him a training simulator where he can do his exercises. Okay. In case something happens, some exceptional cases occur.
Okay, thank you, Kurt. A question for Rolando. You speak about automation. At the end of the road is hydrogen, no, decarbonization, I'm sorry. At the end of the road is hydrogen.
Yeah.
But everybody's asking when hydrogen will be available at a reasonable cost, and when it is going to be feasible.
Yes. Well, the situation of the hydrogen is quite clear. Is the way to have the green steel. When is the real question? Because hydrogen is expensive. We need a lot of energy, electrical energy, to produce it, separating the water, for example. And the situation worldwide is completely different. For example, north of Sweden, as I was mentioning before, they have the electricity, which is practically all green, thanks to aeolic and water and hydro. And in this way, their cost is something like 30 euro per megawatt hour, compared to, for example, Europe, south of Europe is 150. Okay, so there is a big difference. Nobody, one point important is, nobody is ready to do green steel with that higher OPEX. Okay, so if we keep this in mind, we understand that hydrogen, on the point of view of economics, is not coming tomorrow for most of the world. The second point is that hydrogen is not easy to manage. There is today there is nothing ready to transport it. So somebody is saying, I will install something in Europe, for example, in North Africa, and I will produce hydrogen thanks to the solar and so on, and then move up to somewhere in the, it's not so easy. It's not tomorrow.
Not that easy.
Yeah, the way today to transport hydrogen is the tubes on the car, there is a truck with tubes on top for small applications. So making shorter, I think that probably 2040, we will have something done by hydrogen really around the world. Not that is completely changing the situation, but it will be some installations with hydrogen. Honestly, personally, I think that in most parts of the world, the nuclear power will be one of the solutions to make it possible. As we know, nuclear power, it will take, also with the new solutions, the small reactors, it will take 5, 7, 10 years to be developed. Okay, so it's clear that we are today 2024, and 2040 is tomorrow from this point of view.
Okay, thank you. Alexandre, could you provide more specific projects that you're working on in order to produce more efficient plant facilities?
Martín, a importância da segurança tem sido cada vez mais.
Martin, the importance of safety has been addressed a lot. Regulations are increasingly more restrictive. So the use of cameras in Europe has been driven by the case of safety as well. For example, steel producing group in Europe, the Celsa group, they have adopted in their mills the use of artificial vision to, as much as possible, put the operator away from the risk zone, obtaining the measures of the dimensions of the bars. As for the system that I mentioned, mill poles, that totally manages the production process for the mill. It was also adapted in the Celsa group as their standard. So all plants in the group, they use mill pulse as the software to manage production. And besides, they have incorporated another module that we call corporate that gathers all the KPIs from the plants, and the board can manage and compare the KPIs from all plants. I think maybe the best example would be the Celsa group in Europe, where we have applied these solutions. That would be an interesting case to mention. Thank you. Another question for
Digital
Kurt.
technologies applied for CO2 reductions. Quick wins. What can you suggest to do for existing mills?
Where is the big CO2 emission in an integrated mill? It's typically the iron making area. And we've, for example, shown on several projects where we have installed process optimization systems combined with AI, that we can dramatically reduce the coke rate for the pig iron production, and this is directly related to CO2. Some references in Brazil as well. Depending on the previous situation, the gain that can be achieved differs slightly, but you've seen in this one example the payback or the earning was by installing this system at this Russian blast furnace was $5 million per year, and this is unfortunately, I have to say that this is by far beyond the price the customer paid for the system. So the return was for the customer was by far less than half a year. And it's exactly those things that these projects can be implemented in a year, and you have a return on invest of less than half a year. And yes, we need the new technologies for the big steps, but the small steps are there. And it's not only about reducing CO2, those systems also stabilize your process and bring other benefits as well. So there is lots of systems available, and they just need to be implemented.
Make short-term goals, short-term advantages.
Just to quote a sports equipment producer, just do it.
Okay. Okay. Rolando, CBAM, carbon border adjustment mechanism. Can it be effective to push green production technologies outside Europe or not?
Okay, before to talk about that, maybe we should say that today green steel is not well defined. Okay, green steel. Yeah. What is green steel? And then for sure we will have, for sure, I don't know, but we will probably need to fix two levels of green steel. One is for the stream of iron ore, the other one is for the stream of the electrical furnace, I mean the scrap. And this is one of the first points, because it is extremely difficult to understand how we use CBAM, okay? Because, okay, there are three emissions mainly, scope 1, 2, and 3. Scope 1 is the direct emission that is possible to measure. The second one is the electricity, and that the electricity, the way you produce electricity, and that is already a trick, because it depends where in the world you get the electricity, you have your own facilities with solar maybe and so on. But the third one is the most difficult, because it's all the rest, all the materials that you import from somewhere and so on. And the way to measure this is extremely difficult. This is what I think. It is, of course, it is a way to protect, let's say, to support, more than to protect, to support the green in Europe and try to push the surrounding producers, let's say, to follow a similar route. This is mainly the point. Application, we'll see, just started, as you probably know, now in October. Let's see how it works.
I'm receiving a question from the audience for you, Rolando, as well. What is the total steel capacity to be produced on the 44 DANIELI projects, Q1?
Total production, you mean? Or, I don't know now. Okay, we have furnaces that are maybe 80.
Steel capacity.
Yeah, I cannot tell the number, but anyhow, it is, we can consider maybe There are a big one in Algoma, which is doing maybe 1 million tons per year. There is another one in Tokyo Steel, which is similar. There are other melt shops that are producing something like 500,000, 750, 500 million tons per year, 500,000 tons per year, or 750. So the average maybe is we can consider 750 multiplied by 44. Of course, in the total is still a small number. But what is incredible is the number of customers that trust on this in short time. Clearly, all visited this Caesar plant in Croatia, but we were not ready. Okay, we hope, but we didn't expect to have this ramp up for this technology. It's clear that it is understood to be really a good advantage.
Okay. Thank you very much. I'm going to close with a small remark saying that what is clear is that the industry is undergoing a revolution or innovation process that is going fast, that is going very rapidly in order to change all the things we are doing in our production facilities, from how we manage raw materials, how we cast steel, how we roll steel, how we make better services for our customers, how we manage our supply chain and there are new solutions from the digital revolution, from the AI in order to make our production facilities more efficient. I hope that everything that has been talked today is very clear for everybody, and let me switch to Spanish to tell an anecdote. I mean, cuando falamos de tecnología, no es fácil que todo el mundo entienda de qué
When we
estamos hablando.
talk about technology, it's not easy for everyone to understand what we're talking about, but I believe our speakers were very clear. And
Había dos personajes,
we are talking about, there's a story
Einstein, y el otro era
from Albert Einstein and Charles Chaplin. And Albert Einstein wanted to meet Charles Chaplin. And he had this opportunity to meet him during a dinner in London. So Einstein told Chaplin, your art is admirable because without saying a single word, everybody understands what you're doing. Everybody understands your movie, but it's silent. And Chaplin said, well, you are more admirable because everybody admires you, but they don't understand a single word you say. So thank you.